If we remember the particle model for a gas, the particles are far apart, the particles move randomly, a gas has no definite shape, so it will fill a container, and there are very weak forces between the particles. So how does that link to pressure? Gas pressure is caused by the gas particles hitting the sides of their container. For example, the balloons in the picture are full of gas particles, and because their movement is random and fast, the particles will hit and collide with the sides of the balloon. With each collision, the particles exert a force on the container walls. Pressure is the force exerted by the particles per metre squared. Here, for example, if I represent the balloon as the large pink circle and the gas particles inside as the blue circles, because it's a gas, the particles are far apart and they will be moving randomly in all directions. If travelling in the right direction, some of those particles will make collisions with the walls of the balloon. At the point that they make a collision, they will exert a force on the balloon, and the pressure is calculated by the force exerted by the particles per metre squared of the balloon surface. Adding more particles increases pressure. So you can start off with a balloon at low pressure with fewer particles inside, meaning a reduced rate of collisions with the outside wall. If you blow into the balloon, you are adding more particles inside, and therefore there will be an increased frequency of collisions with the walls of the balloon. Hence you are increasing the pressure. So when you blow up a balloon, you are increasing the pressure inside the balloon. Another example, when you pump up a tyre, you are putting more gas particles into the tyre and are increasing the pressure inside the tyre. Changing temperature also affects pressure. If you increase the temperature of a container, you will increase the pressure inside it. So at low temperatures, there is low pressure, and at high temperature, there is high pressure. Here I will show you the effect of temperature on pressure by putting an empty water bottle into a freezer. At the moment, there are air particles inside the bottle. I will put this in the freezer and leave it to cool down, and then come back to it a little bit later to see what's happened. Returning after 20 minutes or so, you'll notice that the bottle appears to be squashed. And that's not due to anything in the freezer squashing the bottle, it's all to do with pressure. By lowering the temperature, we've lowered the pressure, and therefore there is a reduced rate of collisions of the particles with the walls of the bottle. As you can see, as it's warming up, the pressure inside is increasing again, as temperature is increasing, and the bottle expands again, as there is an increased frequency of collisions inside the bottle. And remember, this time we didn't add or take away any particles from inside the bottle. Instead, the changes were all to do with pressure.